use the abacus. We first need to do is we need to understand how to read the abacus. Then after we read the abacus, we will be learning how to add, subtract, multiply, and divide. That's what we're going to be doing. So the first thing we're doing is we're learning how to read the abacus. Oh, thank you. Thank you for the hearts. So we're going to read the abacus first. And then after that, we'll learn how to remove the abacus. And then we're going to do some addition, subtraction, multiplication, and division. So the first thing we're going to do is we're going to understand what we're trying to do. This is my beads. Anytime the beads are touching the horizontal bar, this is the horizontal bar. Anytime the beads are touching the horizontal bar like that, like this is being counted. Because this is being counted, this is 1. Easy? Easy. Easy. So what am I going to do? Now let's just do a review. We have 1, 2, 3, 4. Rain piece 22. Is that still confusing? Yeah, thank you, Jay. So when we're looking, Rain Piece 22 has a number in their name. So Rain Piece 22, 22. That's what 22 looks like. How are we doing? Anybody have any questions? So what we're doing is we're learning how to read the abacus. That's what 22 looks like. Sorry. So this is what 22. So what's going to happen is we're going to look at this maze. When we look at the maze, we're going to look at the number. So I have 89. To do 89, we do 80, we do 9. We have our 8. So 5, 6, 7, 8. So when we're looking, we have 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. That's what we're doing right here. So what I'm doing is I'm going to color it in. 5, 6, 7, 8, and then I do this one. 5, 6, 7, 8, 9. How are we doing? Anybody have any questions? So now, because I do this, oh, I did that wrong. I was supposed to be up here. That's okay. So then we have 21, and that would be 21. And then we got to do 6. 6 looks like over here. So 6 is 5 and a 6. So what we're doing to do 6 is 5, 6. Anytime the beads are touching the horizontal bar, this is what's being counted. So what we're doing is we're learning how to read the abacus. I have to go to here and I'll do 51. To do 51 looks like what? We have a 5 and a 1. When we have it, we have our tens and our ones, our hundreds, our thousands, our 10,000s. Hello, everybody. Welcome. Thank you, everybody, for joining. My name is Lynette. I am an abacus teacher, and I'm going to show you how to read the abacus. This is what I built. I built out a worksheet, and the worksheet is to help you color. And it's supposed to be relaxing. So we did 51, and now we're doing 11. 11, what does 11 look like? 11 looks like this, 1 and a 1. Now, how do I know? Because I have my 1 in the ones and the 1 in the tens. When I color it in, I'm just going to color in 1 and 1, and that's it. Thank you, Jesse. Thank you so much. I appreciate that. We're going to continue on so we can see what it looks like, right? So if I have 48, I got to go here. I got to go 48. So 4, 1, 2, 3, 4, and then 8. 5, 6, 7, 8. So what I'm going to do is I'm going to color it in 4. 1, 2, 3, 4. And then I do 8. 5, 6, 7, 8. Duncan, did that make sense or are you still confused? So when we do 19, we're going to do 19. This is the one we're going to do, 19. To do 19 is a 1 and a 9. So 1, right? 1 and a 9. So what's going to happen, right? I do 1. Does that look like 1? And then 9. We count from here. We count from here. Hey, Derry, welcome back. Duncan, we're going to do 5, 6, 7, 8, 9. Let's do a review. How do you do 6? Oh, that's good. 6, 5, 6. Thank you so much for asking. Takanakuri, thank you so much. Katakuri. So it's 6. Do you see that? Glad to be back. I'm glad to be back too. And it's a little late. It's midnight math, right? So the top bead is 5. The top bead will always be 5. Exactly, Derry. Kata, did that make sense? So we have 5. When we do 5, we do 6. And then 7. How do you get these numbers? Hey, Audrey, welcome back. How do I get the numbers? Well, it's just like counting. 1, 2, 3, 4. Does that make sense? Do you see how I got 4 here? Whew. Let's see. Let's do another way, right? Let's do another way. So, Jackson. So the blue bead on top represents the singular digit at 5. The blue bead is the value of 5 no matter what. So when we're looking, what about the other rows? When we're looking, before I continue on, when we're looking, this is 5, the top bead will always be 5. So it's like a nickel. Pretend that the top bead is a value of 5. It's like a nickel. So when we do 1, 6, this is 5, 6, this is 6. This is 7, right? 5, 6, 7, there's 7. 5, 6, 7, 8, 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. Does that make sense? So, Duncan, about the other rows, we can do 1, 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2, 2. Every column is 2. And then we do 3, 3, 3, 3, 3, 3, 3. And then 4, 4, 4, 4, 4, 4, 4. Duncan, did that make sense? So every column can be labeled. So we have 4s, then we do 5s. When we do 5s, thank you, Jesse. Welcome back. We do 5s. All of this is 5. Hello, Jack. Hi. Thank you so much for the hand heart. Oh, hand heart, right? Thank you, Duncan, for the rose. Does that make sense, Duncan? I'm so happy. I'm hoping that it makes sense. Thank you, Audrey, for the heart me. Does that make sense, Duncan? So much. Thank you so much for the rose. So then we do 6, right? 6, 6, 6, 6, 6, 6, 6, right? And then 7, 7, 7, 7, 7, 7, 7, 8, 8, 8, 8, 8, 8. I should do a song for that. 8. And then we do 9. If this is 9, we have 9, 9, 9, 9, 9, 9. You have so many more views than the last time. Oh, yeah, right. I've always wondered how to read the abacus. Thank you so much, Michael. Right, Jack, you were here for that. I appreciate that. Thank you, everybody, for joining. Thank you, everybody, for joining. I think it's just one of those things. So thank you so much, right, Duncan? So that makes sense. So what we're going to do is we're going to continue on how to read the abacus. So I did I did the 19, and I got to go over here. So now I got to do 81. No, thank you, Duncan, for letting me know that you're confused, because if you didn't tell me, then I wouldn't be able to explain it, right? So the good thing is now we do 81. When we do 81, we're going to do 5, 6, 7, 8, and then we do 1. And then what do I have? I have this number over here, 42. Now, if we're looking along, we have 42, like the answer to the universe. 1, 2, 3, 4, and then 1, 2. We're going to do it again. We have 87. 87. So we have 5, 6, 7, 8, and then 7. 5, 6, 7. So this column is the ones, this column is the tens. Darian, Jack, you guys, it's past my bedtime. Okay, Kata, I'll see you next time. I want this workbook. Oh, yeah. If you're looking for, I'm sold out for right now, but if you want it right now, it's available here. And my name is Lynette. Hello, my name is Lynette. I've been teaching abacus for 20 years, and I've got abacus workbooks to spread to everywhere. I'm making more abacus workbooks, but these are all very abacus specific, and the questions are, once you understand how to use the abacus, then it doesn't matter when you add, subtract, multiply, and divide, you can do it all. Yes, thank you. Jack are the bestest friends, right? I think so. I think you guys are. I'm confused. Again, there, Duncan. Don't expect to learn this tonight. Affirm your joy. Oh, I see. Didn't expect to learn this tonight. Okay, Duncan, how are we doing? What are we doing? So now if we look, every column is a place value. So we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Well done. Thank you for sharing your knowledge in the cheer. As long as people are okay with me laughing, I am perfectly fine. And I've got jokes. So, yeah. So, Duncan, how are we doing? What are we doing? So when we do this, right, we have 87. Oh, that's not that. We got to do 39. To do 39, we do 30, right? This is my tens. Here's my tens. This is 9, and I do 9. Sometimes it's easier if we just did this to do 39. And when we look, we have 3, 1, 2, 3 in the tens column. We have 9, 5, 6, 7, 8, 9. So then what we're going to do is we're going to color in our abacus. 39. 9. And that's it. And then we have 53. 53 looks like that. There's a 5 and then there's a 3. So we do 50 and then we do 3. That's it. Cool. Hey, Cody! Cody! All right. All right. Let's see, guys. Let's see, everyone. It is now your turn to tell me what these numbers are. We are going to be working on an abacus, which is the other way. So if I show you this number, what number do we have? I know this now, right? See, sometimes it's just easier to see when there's because there's too many columns. So if I show you this, what number do we have here? 58. Thank you. Thank you. 58. Yes, it is 58, right? 58. Affirm your joy. Yes, good job. Garden, Cody, Darren, Jack. Oh, I didn't see that one comment. I I don't know how I got here, but now I'm here to learn. So fast. You guys are so funny. Okay, so we're doing 58, right? So 58 looks like that. That's what 58 looks like. So now what do? I'm going to do this number. So if I have this number, I have that, and then I have this. What number do we think this is? Yay! Wow, you guys are smart. You guys are very smart. Good, Derry, Jack, Duncan. See, Duncan? Good, Cody. Good, good, good. RJ. Yes, thank you, Fake. Thank you, Affirm. Thank you, Audrey. It's Leon. Yes. So we have 92. 92 looks like this. And then this is the way. This is the way. Oh my God. Okay, so we have this number and then this number. What number do we think that is? Yay! 14. Thank you, Duncan, Derry. Yes, 14. Awesome. Everybody, welcome, welcome, welcome. So we have number 14. And now we have this number. This one's easy. How? Because we have every digit, right? So we have 4, 1, 2, 3, 4. And then we have 1, 2, 3, 4. Very like an avatar. Okay, yeah. So does that make sense? 44. Almost, almost. 13 looks like this. 1 and a 3. That's what 13 looks like. So right now we're going to do 44. Every column, right, is a digit, is a place value. So 44 takes me to here, and now I'm over here. Now remember, the top bead is a value of 5. And then if we add the bottom bead, now we have 6. So we have 5 and 6. Thank you, Jack. I didn't know the being, now I know it, right? So how do we know? The top beat is a 5, the bottom beat are a value of 1. So we have 6 and 6. Thank you everybody for 66. Fake, Jack, Dairy, Affirm, Garden. Yay! You guys are so awesome. Right, Duncan? Right. So sometimes it's just easier to move it with the column isolator. So how do we know what this number is? Well, we have 3 here, 1, 2, 3, and then the top bead is 5. I just learned this today. I just came in minutes ago. Ah, this is so awesome, you guys. Okay, 35, 35. Duncan. Oh, Duncan updated it. Yep. Garden, Fake, Faco, and Dairy, and Jack. Yes, yes. You guys are doing very good. 35. I'm going to take it to here. So then we have this number. Can we see that number? So we're reading the abacus, and after we read the abacus, we'll learn how to add on the abacus. And we do 5, and then this is 5, 6, 7. Thank you, 57. Thank you, Belly, 57. Yes. Thank you, Jesse. Thank you, Affirm your joy. Thank you, Garden. Yes. Thank you, guys. Awesome, right? Thank you so much for joining. Thank you so much for coming. Now I don't feel so alone. So what number do we think this is? If I have my 2, that's a 2. And then I have this number, right? We have 20. Oh, good job. 29. A couple of nights ago. Oh, yay. Welcome back, Belly. I need my Yep. Right? Thank you. 29. So we have 29. And then it will take me to here. We know this number. Oh, thank you guys so much for the heart me. Hello, Mary. Thank you so much. We know this number. What number is that? That number is this number. Was scrolling and actually clicked the live, and I'm glad I stayed. Zero. It is zero. Thank you guys. Thank you so much. Right? That's what, it is zero. It is zero. I was trying to trick you guys. So it's funny. My kids actually accidentally come to my live too, and they're like, no, no, I don't want to be part of her live. So I understand. So what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we will start it going into understanding how to use the abacus. So yes, it is 47. 1, 2, 3, 4, and then we have 7. 5, 6, 7. Thank you. Thank you. Affirm. Thank you. It's Leon. Thank you. Derry, Duncan, Fake, Jack. Awesome. So 47 takes me to here. And then my final, no, I have another one. So what number do we think this is? The algorithm here, what? Oh, gotta go. Okay, Duncan, see you later. Thank you so much for dropping by. I'm so fast. Yes, right? Oh, so the answer is what? The answer is 6, 5, 6, and then we have 2. 1, 2. Does that make sense? Yes. Yes. There you go faster. Thank you, Jesse. Affirm. 66 looks like this. This is a 5 and a 6. That's what 66 is. Will you be here tomorrow? Yes, I will be here tomorrow. Oh my God. Thank you, poetic. Yes, right? Oh, you guys were talking about you guys. Yeah. So if we do 62, that's what 62 looks like. Yeah. Got it. Good, good, good. So 62. And then my final answer is, what's my final answer? We have our answer here. So we have, yeah, 60, almost. Oh, there you go, Jack. Yep, fake. We have 60, we have 3. All right. Are we ready for it? Are we ready for heavy hitting now? Wow, my gosh, you guys, so awesome. Thank you so much for the loves. Hey, teacher, hey, users 37397. Hello, thank you so much for dropping by. Let's go. Okay, so we learned how to read the abacus. We're done. We're ready for the abacus. Okay, so what's the next thing? The next thing, 老师, thank you so much, poetic equation. Okay, there is no way to fix it. What are we going to do? What we're going to do is we're going to read the abacus. Now, before we read the abacus, we're going to understand is when we move the beads, we want to be happy and we want to be gentle. So when we move the beads, you're going to use the edge of the bead. Notice that there's a pointy, that's a little bit pointy. So when we're looking, right, when I move the abacus, I'm using the edges of the beads to move the abacus. So when we're looking, right, we don't want to be aggressive. Don't be aggressive because every time you're aggressive, you're going to mess up your answer. So the idea is you want to be intentional when you move the abacus. You want to be intentional when you move the beads. You don't, because if you do this and you flick, then you flick too hard. Don't flick too hard and you'll be fine. So when you do it, you'll understand that it's like a rattle. But because it's a rattle, it's easy to bump. If it's easy to bump, then what's going to happen is you're going to mess up your answer. So you want to make sure you not to flick too hard. Thank you everybody for joining. Thank you. It's Leon for the heart me. Thank you everybody for joining. Please make sure you keep your mind open. So what we're going to do is we're going to start understanding how to move the beads. When we understand how to move the beads, this is also available in my TikTok shop. And so what we're going to do is we're going to understand how to move the beads. We already understand how to read the beads. We got it. We're not a problem, right? So now what we're going to do is we're going to understand that in abacus world, we focus on the result. We focus on the add-in. We focus about the process. It's all about the process and not about the result. What do you want to do? You want to be able to divorce the result, marry the process. So what does that mean? Well, if I have my question here is 5. I have 5, I'm going to add 5. Now the question here is, can I add the 1? When I add the 1, do I have enough to add the 1? When I add, I'm going to the horizontal bar. Do I have enough? Can we add the 1? Yes, we can. We can add the 1. So because we can add the 1, I'm just going to add the 1. My final answer is now 6. Does that make sense? So what we're going to do is we're going to understand that we got to focus on what the number is going to be. So what we're going to what are we trying to add? What are we trying to subtract? We don't want to look at the result. We want to look at the add-in. So we do it again for the 2. The way this book is broken up is that it's to understand the add-in. So here I have 6. I'm going to add 2. Can I add the 2? Yes, we can add the 2, so we add the 2. That's all I'm doing. So my final answer is 8. How do I know that this is 8? I know this is 8 because I have a 5, 6, 7, 8. And if you notice, it's easy to supertize. Supertizing means to be able to look at a number, to be able to look at your object, and be able to know that that's 8. So we practice how to read, right? And because we practice how to read, we understand that this is 8. It is very different than mainstream world. Why? Because in mainstream world, we're starting with they use dots, and then you got to recount it. 1, 2, 3, 4, 5, 6, 7, 8. However, when we do it on the abacus, I know if I have the 5 and I add the 3, it's easy to see that this is 8. So what's going to happen is what? What's going to happen is that when we look, we know that this is 9. Again, we add, we go to the horizontal bar. We subtract, we go away from the horizontal bar. So if you notice, I just took away 6. I added 6, I take away the 6. So again, we're going to do the same thing with the 4. When we do the 4, we have 5 and we add the 4. Is there enough to add the 4? Yes, there is enough to add the 4. My final answer is 9. That's it. So what's going to happen? Well, because we know how to subtract, we will know how to because we know how to add, we will know how to subtract. So what happens? What we're going to do is we're going to add 3 to the abacus, right? To add the 3, we're going to the horizontal bar. We're going to subtract. When we subtract, we want to subtract the 1. Again, we're going to understand the process. We're going to look at our second number. We're going to subtract it. We got to take it away. That's what we can do. So anybody have any other questions? Let me know and we will continue on. So we might be wondering, well, what about the 2? Same thing. It's exactly the same. So if I have 3 and I want to take away the 2, I'm just going to take away the 2. That's all I'm doing. I'm taking away these 2 beads. It doesn't matter which 2 beads, as long as it's two sets of beads, right? One set of beads that has 2. And then if I look at here, if I do 2 and I take away 2, then my answer is 0. But I'm only moving these 2 beads. And what we're doing is we're understanding how to move the beads, right? And it's the same thing with the 3. If I have 4, I want to take away 3. All I got to do is just take away the 3. That's it. Anybody have any questions? Oh, yeah. Right? So what's going to happen is, well, we know how to do 4. 4 is not very difficult. Why? Because it's the whole bead. So if we add the 4, we take away the 4. We add the 4, take away the 4. You'll notice that it's very you know how to do one way, you know how to do the other, and it becomes a balance. And then after we know how to do the 4, we can all go into understanding how to do the 5. The 5 is easy. So if I have 3, I'm going to add my 3, and again, when I add the 5, I just need to bring it down to the horizontal bar. Does that make sense? When I take it away, right? That's a subtraction. So when I do minus the 5, I subtract it. I take it away from the horizontal bar. When I add, it's to the horizontal bar, right? So it's again when we do the 6. A 6 is the same, and you're going to start seeing that there's a number pattern. When we have 9 and I want to take away the 6, right? If I have 1 and I want to add the 6, notice it's 1 bead on top and 1 bead on bottom that makes the 6. So when we're adding it or we subtract it, we add, we subtract. So what we're going to do is we're going to take away the 5 or we take away the 6. Does that make sense? How is everything going? Right? So what's going to happen is we have 7. After 7, we have 1 and then 7. We add 7 or we take away the 7. We add the 7, we take away the 7. So our final answer is 8, right? My brain is fried. Well, it's also very late, Edgar. It's very late. It's very late to be learning math right now. Okay, so what's going to happen is when we read it, let's do a little review for Edgar. Edgar, are you still around? What I'm going to do is I'm going to show you how to count. We're going to do a review. We're going to do 1, 2, 3, 4. That's great. User 397. Okay, what's going on? Supertize. Supertize is a new word. I missed the beginning of the bead, columns 10 sections. So what's going to happen, poetic equation? Every column is a every column is a place value. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. Edgar, how are you doing? You all right? So what's going on? What we're doing is we're understanding how to read the abacus. Anytime the beads are touching the horizontal bar, that's what's being counted. So we got it, right? Oh, good poetic equation. So we have we have one and then five. The top beat is always five. Then we have 5, 6. This together is 6. Then we have 7, right? 5, 6, 7. And then 8. 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. Does that make sense? I don't know if Edgar's still around. Edgar, you still here? So what we're doing is we're understanding how to read the abacus. Why? Oh, that's a good question, Mary. Yes. The reason why is because if you notice, I have this dot indicator. This is my ones indicator. I have two, if you notice. If you choose, you could choose one of them. You could choose this one, and then you would have to shift everything over. So it'd be my ones, my tens, my hundreds, I'm sorry. 1, 2, 3, 4, and then 5, and then 6, 7, 8, 9, and then 10. So then 10, 20, 30, 40. Unless you choose this one. Until this one. Right? And so what's going to happen is now I have my ones. I have my ones. So I have my 1, 2, 3, 4, and then 5. The top beat is 5. And then we have 6, 7, 8, 9, and then 10. Does that make sense? I love the audio. Oh, okay. I'll see you later. Thank you again. Not a problem. It's Leon. I hope to see you in my next live. Thank you so much. I love the audios, you sir. You have certain words you say. Oh, okay. Belly and Derry and Jerry, if you, Jack, if you have a specific question about abacus, please let me know. If not, please have the conversation somewhere else because you're confusing me and I'm reading all the comments and it doesn't make sense to me about this couch. Right? So if you guys could, please take the conversation somewhere else. Not a problem. Thank you. Okay. So what we're going to do is everybody's okay now. I don't know if Edgar is still around. Edgar, what we're doing is we're going to learn how to read the abacus. Why would you use this over something else? Make it easier to count? No, it does more than just counting because we can actually what we do is we can do adding, subtracting, multiplication, division. But see, the thing is it's easier to see the numbers and you'll get to see it when we can scale it up. But the first thing we need to do is we need to understand how to put a jacket on and we're going to take the jacket off. So this is the fundamentals and understanding how to use it. If that makes sense, Nix. Yeah? So ideally, you could use your blocks, you could use like counting bears, but those are very individual. However, in abacus, we also provide critical thinking and in the beginning parts of algebra. So there's a lot of algebra concepts that happen in abacus. Yes. No, it's a very good question. It's a very good question. It's just another tool, but it's not. It's actually a forgotten tool. And so the interesting thing is if you see those kids that do this, it's because they're doing the abacus. There's more to it than just counting. There's a formula and a workflow and critical thinking. But the first thing we're going to do is we're going to understand how to move the beads and what we're trying to do. So we did this, and I don't know if Edgar's still around, but we're going to continue on. So what we did is we understood how to add and we're going to take away. We know how to add, we know how to take away. We don't have separate strategies to take away. It's the same thing, just the opposite. So when I add, I'm going to add the 5. When I subtract, I'm going to subtract the 5. Does that make sense, Nix? Right? Poetic equation. So what we're going to do is we're going to add the 6, and then if I'm going to take away the 5, I can add the 6, right? If you notice, I'm starting to show you that there's number patterns. Because I have this, I can add it. Do all the abacus have the dots? Oh, that's a good question. Affirm your joy. It does. So this one is a 13-column abacus. This 13-column abacus also has the dots, and you can choose any one you want because this is a 13 columns. That means I have more digits that I can utilize. This one is only 7 columns, so you know what that means, right? Size matters. So when we're looking, right, if I choose this dot over here, I can have my ones, my thousands. If you notice, they're grouped, right? So my ones, my thousands, my millions, my billions, my trillions. Does that make sense? So if I choose this one, then I move everything over and I can do my ones, my thousands, and my millions. But everyone, there's the modern abacus has dots. Even the one that I have. So if I want to track the national debt, I can use my 23 column abacus, but I think it's a little bit overkill, but I still have dots on this one. So they started off with having dots. This one is a Japanese abacus. The Chinese abacus does not have dots. The ones that I've seen does not have dots. So what the Japanese did is they made it more efficient and made it more elegant. Efficient and more obvious. So that's where the dots are. So if you notice, if I choose this one, every dot placement is a comma in our decimal system, if that makes sense, right? But that's a very good question. Thank you so much for asking. I do appreciate that. And yeah, and that's why we do it. So it doesn't matter if you have the small abacus or if you have the big abacus. Even if you have this big abacus, you could still do the small numbers. It's the same thing. The difference is just the color doesn't make a difference either. It's all about the placement of the beads. So if I have 7 over here, I'm going to have 7 on my abacus, and I want to take away the 5. All I got to do is take away the 5, and that's it. Right? Make sense? Thank you so much. Thank you. Affirm your joy and marry. Poetic equation, does that make sense? I don't know if Edgar is still around. Okay. So, thank you everybody for joining. Thank you. What we're doing is we're learning how to read the abacus and we are moving the beads. So, what we're going to do is I'm going to continue on with this one over here. And then we are here. So we have 7. No, we have 8. How do I know? 5, 6, 7, 8. And we take away the 6. When I take away the 6, we do that. And then we have 2. My final answer is 2. And this is 7. So what we're going to do is we're going to have 5. We add the 4. And then I want to take away the 7. Notice, right? I want to take away the 7. I just move it like that. And that's it. So now we can actually translate it. What does that mean? Well, when we have bigger numbers like this, it's easy to see. Because what do? We have 283. 283. Guess what? What we got to do is we're going to add 511. We don't need to do friendly numbers. We just have to make sure that our abacus is correct and if we have enough beads. So if I have 5, I want to add the 5 here. I need to add the 5 here. Do I have enough to add the 5? Can I do it? Yep, I can do it. Can I add the 1? Yes, I can add the 1. Can I add another one? Yes, I can add another one. So my final answer is what? 7,904. So this is what I'm showing you is that now it's scalable. Understanding how to read the abacus, now we know how to scale it. So anybody have any questions? We can do a review. Hello everybody, my name is Lynette. I am an abacus teacher and I've been teaching abacus for 20 plus years now. I am now making abacus workbooks because there's not enough abacus workbooks out there, and I make my abacus workbooks entertaining and engaging. So if you look, I have all these activities that the kids can do. If you're wanting to, I have that too. That's why I built out the mazes. The mazes are kind of cool too. And we did a couple of mazes, and the mazes was meant to enforce how to read the abacus, how to read the numbers, and that's what these are. Can you multiply with this? Hey, Iggy, yes, we can multiply with this. No, it's not too hard. It's not too hard. If you just take some time to understand it, it'll be fine. People would be able to learn it. A lot of people was able to learn it within 5 minutes? But coming in, you got to take a little bit of time to understand. So, what happens when we don't have enough? Let's do a little review. 4 Andres, but I'm not sure if Andres is still here. I can show you. I can show you multiplication in a little bit. Can I put a pin in that? So what I'm going to do first is I'm going to count. We're going to review. I was young when these class and I didn't think the teacher knew how to do it. Yes. Okay, good. So what we're going to do is we're going to count. Anytime the beads are touching the horizontal bar, this is what's being counted. So this is 1. This is 2. This is 3. And this is 4. And then what? This is 5. After 5, we have 6. We have 7. We have 8. We have 9. Yeah, hold on, Hollywood. I'll be right there. Let me just finish doing a review for Andres. Yeah? So we have 10. 10 is over here. Why is this 10? 10 is my tens. I have every place value. So I have ones, tens, hundreds, thousands, 10,000s. Yep. Makes sense? So when I look, I have 11, right? 12, 13, 14, and then 15. After 15, I have 16, 17, 18, 19, and then 20. Andre, does that make sense? Okay. Hollywood. All right, cool. We are going to go on to multiplication really quick. So it made sense. Okay, good. So when we're looking at it, what we want to do is we want to understand how to use it, right? So that's why that's why I showed you how to do it on this. To do this is easy because we have to just to see if we have enough beats. So we have 283. My question is can I add the 5? I think that's where you came in. Can I add the 5? Yes or no? Let me know in the chat if we can add the 5 right here. Can I add the 5? In this column, can I add the 5? Do I have enough beads to add the 5? Yes. Thank you, Mary. I do. So then I go to the next one. Thank you, Kitty. I have 1 and I add another one. So my final answer is 798. Okay. So we know how to read the abacus, Lynette. Now what are we going to do? Okay. Let's push the class forward to multiplication, but then we got to go back to addition because there's more to addition than just what I did. Because we have these formulas that we need to understand. But before we do that, let's do a little bit. I don't get it. Hello, Katie on the daily. You don't get what? You don't get how to read the abacus? That this is 1? Does that make sense? Thank you, Hollywood 974. Right? I just got here. Okay, you're going to have to bear with me because I'm going to go to multiplication and we'll come back. So, multiplication. Okay, let's go to multiplication and we'll just come back. Hold on, Katie on the daily. If you have a little bit of time, I'm going to move the class to multiplication first, and then we're going to move back to how to read the abacus. Hold, please. Okay, so what are we going to do? Now, the first thing in multiplication is we have this thing called distributive property. That is an algebraic term, I believe, or it's a math terminology. And in multiplication for abacus, what we do is we understand how to do distributive property. I should write it out. Distributive property. Property. Ha! I don't even know if you can read that. All right. So what's going to happen is we're going to understand our distributive property. When we look, we need to count our digits. Why are we going to count our digits? We're going to count our digits because we need to know where to put our answer. So what's going to happen is we need to understand where to put our answer. So we have 1, 2, 3. Does that make sense? Let me see if I can move that a little bit. Right? 1, 2, 3. So we counted three digits. 1, 2, 3. I'm starting at my ones and I count. So I'm going to be at the hundreds. Does that make sense? Because I'm at the hundreds, now you're going to have to tell me multiplication facts because I'm a little tired. So if my question, I go from 8 times 9. 8 times 9 is what? Let me know. Hello, Duncan. Welcome back. Let me know what 8 times 9 is. 8 times 9, thank you, 72. Now, thank you, Duncan. Thank you, Katie. I'm going to add 70. There's my 70. I'm going to add my 2. Now, the difference is if you notice, I have 7, 7, 2, 0. This is my 0. This is my ones place, 720. In abacus world, we just need to know our multiplication fact. In mainstream, we write it, they write it out. So they would do 90 times 8. Oh, you can't see that. My head's in the way. So what's going to happen is they do 90 times 8, and then they give you 720. We don't need to do this in abacus world. In abacus world, we just need to know our multiplication fact. So the next thing we're going to do is what? We're going to add 8. I'm sorry, we're going to times 8 times 3. What is 8 times 3? Thank you, Nico, for the follow. 24. Thank you. 24. So my question is, can I add the 2? Yes. Thank you, Mary. I can add the 2. Now I go to add the 4. When I add the 4, my final answer is what? My final answer is, hey, Striker, welcome back. Wow, I missed a whole lot of questions. Okay, what's my answer here? How do we read this? My hundreds? Yes, thank you, Mary. My hundreds, my tens, and my ones. Thank you, Affirm. Thank you, Brandon. Thank you, Iggy. Thank you, Hollywood. Does that make sense? So what did we just do? We just did multiplication. We had to understand and memorize our multiplication fact, and then see, Katie, if you just hang out a little bit, you'll get it. You'll get it. It's really easy. Incredible, right? Yeah. I'm telling you, it's pretty cool. It's really cool. And it's fascinating because it's just, everybody, thank you everybody for joining, and thank you for keeping your mind open to something new. Nico, thank you so much for your awesome gift. Thank you so much. I'm confused. Did you add at some point? I looked at my abacus and I checked to see if I had enough beads. That's what I did. So what I did was, I have 72. I put 70, right? I put 70 and I put 2, right? And then what's going to happen? I put 24. Do I have enough to add the 24? Yes, I have enough to add the 24. So I'm going to add the 2, and then over here I add the 4. And that's it. Too confusing. Your one's in the wrong placement line. They're supposed to be the farthest right. The dish pit guy. No, because we have a ones indicator right here. So with the ones indicator, I can be here. This will be my decimals. So I can actually do money. If I did money, right, then I can do $744.25. That's what these two columns would be. The dish pit guy. Oh, here, let me show you. So if I did this, right, we have 744.25. That's what that looks like. 744 point sits between the two columns, and then 25. I'm not, that's what? Whoa. Whoa, no, 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 we're okay. We're okay. It's just a different way of thinking. That Calm down, people. Calm down. Right? Calm down. So what happens is, no, 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 calm down. Calm down. It's okay. It's okay because it's a different way of thinking. It's a very different way of thinking. Hey, Jeffers, welcome back. How's your abacus doing? Okay, okay. Calm down, calm down, calm down. So it's confusing to put 72 in the hundreds. That part went too fast. Oh, you know why? Because I counted my digits. So when I counted it, I counted 1, 2, 3. I know because I'm going to do 3, I have to be in the hundreds. So I'm going to know that's going to be part of the hundreds. That's why. But in mainstream math, we don't do that. In mainstream math, they do 90 times 8. But in abacus, we just need to count our digits. We use the abacus to keep track of our digits. So when we did 1, 2, 3, right? We do 1, 2, 3. We're following the numbers. So when I do 8 times 9, it's kind of like 8 times 90. But if I do 72 on my abacus, I have 720. Because I have 720, right? I don't need to worry about the 0 because I just need to worry about where I put my place value. Gosh, work. I noticed myself thinking, yeah, Jeffers, right? Thank you. I know. It's really addicting when you get to it and you start seeing it. You're going to see how the 5 works, and you're going to have to see how the 10 work. It's amazing. The geniuses do fast math in their way. Yeah. So, the dish pit guy, did that make sense? Uh, Hollywood, you okay? Hollywood, you all right? Okay, what are we doing? We can do another. My calculations and hands were super sappy. Yeah. Okay. So that's what we're doing. So let's go back. Let's go back. Let's do some adding and subtracting because we want to understand the concepts. Technology is dumbing us down, and I love the rediscovery. Yes, I appreciate that. Thank you so much. Everybody who comes in the live are always like, this is not what I expected to learn. All right, let's move forward. Let's move forward. I'm trying to take it all in. Okay, let's do, you know what? Let's move back. Let's move back. I was dumb math without technology. All right. So the first thing we're going to do, not the first thing, the next thing we're going to do is we're going to understand there's a bigger concept to adding and subtracting than what meets the eye, like Transformers. Oh my God, I need to get that sound bit. Like Transformers. Oh my God. I gotta make that. Okay, I'm gonna make a note of that. I gotta get a sound bit about Transformers. More than meets the eye. Oh yeah, right. Transformers. Oh, okay. What are we doing? Okay. When we add the five, what we're gonna do is we're gonna do some. What does that mean? That means that we have these things called number addition sentences. We have these things called addition sentences. Oh, Icky, you're welcome. I appreciate that. I appreciate your generosity. And thank you so much for joining. Thank you everybody for joining and opening your mind. So what's going to happen is we're going to understand how to add, let's do this one, 3. We're going to add 3 on the abacus. When we add 3 on the abacus, let me get my abacus, and you'll notice when I add the 3, hello, Chloe. You're not late. You're on time. It'll just take me a little bit to retract, but you're good. You're good. So we have 3. We're going to add 3. We have 3 on the abacus and we have 4. Well, I don't know what's going on, but you know what? Let's take a look. We have 4, but it's kind of difficult to see on the abacus. All right, so let's do. I'm sorry, we do 3. So let's do 3. 1, 2, 3. I want to add 4, but guess what? Hey, Scarface! Long time. It's been a little bit, hasn't it? Thank you, Jeffers. But before I do that, what we're going to do is we're going to add the 4. But you know what? I don't have any more beads to add the 4. I do, though. I do have a nickel. I do have 5 cents. Because I have 5 cents, I'm going to give you my 5 cents, but that's too much because I only need to give you 4. So I'm going to take away the 1. I can show you on my abacus. My final answer is 7. I can show you on my abacus. I do 5 and then take away the 1. And my final answer is 7. Does that make sense? So what did we just do? We power up our addition sentence. We can do it again. Now we're getting this concept. We have this concept to understand. We have 4. Because we have 4, I want to add another 4. If I have 4 on my abacus, I want to add another 4. Because I want to add another 4, I don't have any more loose change. But guess what? I have this nickel. Because I have this nickel, that's too much. I need to take away the 1. I can show you on my abacus. I add the 5 and I take away the 1. Does that make sense? So what did I just do? That was a concept. The concept is everybody who is learning, the kids are teaching, the teachers are teaching the kids 4 plus 1 is equal to 5. So what did we just do? What we just did is we did some modification. Modified, right? So what we're doing is we're not going to memorize our doubles. We're not going to memorize this. I'm old. I did not learn abacus when I was a kid. What I did is I learned abacus when I was a big kid, an old one. And I was like, this is crazy. Why are we doing this? But then I realized this is actually the greatest thing next to sliced bread. We're not going to memorize that 4 plus 4. I would love to be able to do this as fast as you can. You can. You just need to practice. You know what? You guys are fast. You're fast at typing on the keyboard. As fast as you are typing on the keyboard, you can be as fast on the abacus. Right? Ah, you guys, you know what I mean? Everybody keeps asking, like, can you be as fast? Yes, if you can play the piano and you know how to where all the keys are, you'll be able to do the abacus, not a problem, right? So what we're going to do is we're going to do it again. If I have two on my abacus, I have two on my abacus, and there's two on my abacus. I want to give you four, but I don't have enough. I'm going to give you my 5 cents, but guess what? That's too much. I'm going to take away the one. So because I take away the one, my final answer is six. I can show you on my abacus. I can add the five, and I need to take away the one. So what did we just do? Guess what we just did? We did some modification. So what's going to happen is, I will show you. What we did is an algebraic thing. The algebraic. What did we do? We took our addition sentence. 4 plus 1 is equal to 5. Guess what we did? We isolated the variable. It's not an unknown variable. It is a variable, right? It's a known variable. The variable is the 4. So what we did is we added the 4, and what we did is we moved the 1 to the other side. So we balanced the equation, right? If I want the 4 to equals to 5 minus 1, just as Jeffer says. And so what happens is it looks very familiar. Let's make it to an unknown variable. Unknown variable looks like this. What? Right? It is algebraic. Abacus is the beginning, is the gateway to Abacus is the gateway to complex math. Make fun learning. Thank you. Thank you, Mary. Yes. Some people were like, oh my God. Hey, Nan, son, welcome back. You guys. Awesome, right? Cool. Cool. So does that make sense? So what did we just do? Put abacus back in school. I don't think abacuses were ever in school because school, the math that we're doing is very Eurocentric. I learned that word and I'm like, oh my God, that makes sense. It is Eurocentric. And it's like interesting because we got the Arabic numbers, but we didn't carry on the abacus stuff, which is really like, okay, well, whatever. You know what I mean? But I'm planning to go. My path is to educate as many people as possible so we can bring it into mainstream school. That's why I use math terminologies like isolating the variable and substituting. In abacus world, we actually don't do any of that. We just say, do it. Do it, do it, do it, do it. I don't know if you guys ever saw that. Was it Starsky and Hutch? He says, who is it? Ben Stiller, do it, do it, do it, just do it, just do it. Interesting. Can you show us more complex example? You know what? Yes, we will. It's weird because multiplication seems easier than addition on the abacus. I love learning math, especially here. You make it fun. Ah, thank you. And it's so true. The kids knew new math. Oh yeah, new math. Woof, new math. Anyways, so you know what? Let's do another one. Here it is. Here it is. So here's my question. Here is my question. Let me erase the answer. All right. So what are we doing? Let's do this one. It's the same, but now now it's what? It is it's scalable, right? So we have this big number. 3, 1, 3, 5, 7, 8, right? 13,578. What are we going to do? We're going to add 24,311. Guess what? Well, can we add the 2? Yes, we can add the 2, right? Can we add the 4? We're right here. Can we add the 4? Remember what we just did? Remember what we did? We're going to add the 5 and take away the 1. And then here, can I add the 3? Can I add the 3? Yes, I can. Can I add the 1? Yes, I can. And I'm over here. I have 8. Can I add the 1? Yes. Thank you, Jeffers. Yes. Okay, Hollywood, I'll see you later. Thank you so much for coming by. And hopefully I'll see you in my next live. So what is my final answer? My final answer is 37,000, 889. Thank you, Jeffers. Math like this makes it intuitive, right? Yeah. Why do you choose the Japanese abacus over the Chinese? I think it's because it's more modern. The Japanese abacus became more modern. Then there's not too many people that do Chinese abacus anymore. Like in um, the world around, India has taken over the soroban. They're starting to do Vedic math, but that doesn't have to do with the abacus. Singapore does soroban. Almost everywhere around the world has taken on the modern abacus, if that makes sense. Oh, thank you. Added to the Amazon cart. That's cool. Yeah, you can choose any one, any sizes as well. I have this one because it's nice and it's pretty to look at. But I feel like that if I have 13 columns of here, if I have 13 columns colorful, I think it'd be overwhelming. I think having the colors for small is nice, and then when I use the 13 column one, it's a single color, and I like that. So the round beads don't have the contact and the visual appeal. The round ones, no, it's not the visual appeal. Will I be here tomorrow? Yes, I'll be here tomorrow. No, the round one is not. It's not that it's not visually appealing because it works exactly the same. It works very similar. The thing I think is it's just it's just a little redundant. So I do one, two, three, four, five, and then we do five. So if I do this, we have to trade it in. So we do that. That's five. And then we do six, seven, eight, nine, 10. And then we have to trade this in to here. But then we have to trade this in to here. So it's a little bit more steps, which is interesting. I like the pointy. Yeah, I like it too. I like how it's pointy. Can you show us what we can do when we run into decimals? That confuses me someday. Okay, yeah. Yeah, decimals is not that different. The difference is what? It's just a different place value. So here's the question. Let's do this one. Let me find paper. Okay. So even if we had this one, right? We're gonna do two decimals if that's okay. We'll do 500.34. So I'm sorry, not 500. 534. And that's it. Oh, I'm sorry. Wait. When we use the coins, it's assumed that we knew the answers. When we use the coins, is it assumed that we knew the answer? No. You don't want to you have to divorce the result, marry the process, right? So I got to redo math. Okay. Thank you. It seems we're subtracting from the answer. We're not subtracting from the answer. Okay. Um, where was it? Scarface. Did that? I mean, so we're gonna add. Are we adding Scarface? So when we add it, this is all we're doing. So when we're looking, we have our ones, our tenths, and our hundreds. So right here is our decimals. That's it. That's all we're doing. So, oh, I thought you skipped a space. No. Oh yeah, yeah. That's the funny thing. This is not a dot. What it is, it sits between. Yeah, I was taught to add starting in this ones place. The abacus line, we always start from left. Most always? No, not always. It just depends on where you want. Ah, Michael R. Since the Chinese one has two steps, it's less columns than the Japanese. No, there can be big ones. There can be big big Chinese ones too. That's just the one I have. Yeah. Okay. So back to this one. Yes, we do subtraction. Hello, Michael R. Abacus land. Yeah, thank you. So, who is it? I was missing. Yes, we are taking away as well as, but see, the thing is, what are we doing? We are adding, what we did is we have too much. So you have to compensate, right? So if I have three on my abacus, I have three on my abacus. I have the four. When I have the four, what's going to happen? I don't have any more beads. Remember when you give out change? When you give out change, you pay a little bit extra, right? But you're expecting change back. Because Kitty, when you expect change back, right? I get the five, but what do? I need change back. So what's going to happen is I need to take away the one. What is an abacus to be modern or not? Just because the dots? No, modern because it's Modern because it's one bead on top and four beads on the bottom. I get it, but the kids don't know the answer. It's subtracting. The kids will understand to balance the equation. How can you get an wait, I'm sorry. How can you do abacus in your head even if you don't have an actual abacus? You kind of need an abacus because you need to see how it moves. I mean, the ones with the two beads, the top beads, the larger is less columns. The one with the two on the top, you can have larger numbers with less columns. You can, but it gets confusing because if I do this, what number is that? Right? It gets confusing because why? This is 110? No, it's 120 because this is now out of place. So it gets a little confusing if you don't track it. That's why you trade it in. So this becomes traded and you do that. Oh, I'm sorry. I even got that wrong. So this is 130, right? Because you need to know that this is 10. So you have to be careful. Add the 5 and take away the 2. Yep. Take away the 1. Yeah. That's how we do the minus 4. Yeah. So yeah, it's one thing to be able to also trade. So when we're doing this, this is 10. If I do this, this is 15. And I was like, this is 15, but I have to count it. Like I don't see this as 15. So because I don't use I don't use the Chinese abacus very often. So I don't remember it. But then if I do this and I do this is 20. I'm like, I'm going to have to know that this is 20. So I trade it in to make that 20. And then now it becomes more regular because every column is a place value. Can you do fractions? Fractions is just another way of doing division. So decimals, yeah, you could do decimals. And we were talking about decimals. Decimals is just this. If I had 5 dollars and 34 cents, 534. That's it. Yeah, I don't like that one. Yeah, it's a little confusing, right? So, but yeah. So that's how we do the decimals. And when we do the decimals, Yami, it's the same. So we could do here, right? Or we can go here. If we did this one to be our decimals, we can do 5, 3, 4, and then we can continue on. We can do 7, 8, 9. So it'd be 7, 8, 9 because I said that this would be my ones place. So it all just depends where you are and how big your number is. It can be bigger, it can be smaller. Does the abacus you have called? Oh, it's called a soroban. Soroban. That's what it is. Miss Audrey Abacus had two. I saw it. What's hers called? Audrey's Abacus. But it was late for her. Give her a break. It was late for her when she was drawing it out. So she says, but I don't think she sleeps. I don't know if she's here, but I don't think Audrey sleeps. She's such a funny lady. All right. So we have that. We have that. I'm going to have to create I'm going to create. Oh, yeah, you can. It'd be great. Let me see. If you ever create one, I would suggest if you want to do 5, then you can have 2 columns for decimals and then 3 columns, hundreds, ones, tens, and hundreds. You can do as big as mine. It's up to you. But as long as you try to leave for at least 2 beads for the decimals, so then you can do money as well. That's what I would suggest. It doesn't matter how big. I would try to leave 2 for decimals. So that's why I always start here. Cool. How are we doing? Okay. So the kids, okay, now going back to the kids. With the kids, we don't tell them add the 5, take away the 2. We don't tell them I have a 5 penny and so forth. So going back to this scenario, when I was building out my workbook, I would say I have 5 cats in a tree, right? Can you do? Yeah, we can do a multiplying again. Yeah, we could do it. Your class inspired. Oh, thank you so much. So what do I do? Okay, so this one, if I was to teach the kids, The kids, it's always about the kids. So if I teach the kids, if I have three on my abacus, I have three on my abacus, I add four, I look at them, do I have enough to add the four? And they'll say, no, I don't have enough beads to add the four. Guess what? That's why we have five cats in a tree. And you take my hand out, I go, I have five cats in the tree. I go to the five cats, right? I go to the tree with the five cats. Because I have the tree with the five cats, I grab four cats. One cat runs away. So one cat needs to run away. And then my left with seven. That's how I would teach the kids. That's why I have it built out this way. This book was meant for children from ages 4 to 7. Customer, sorry, use the instead. Yeah. You know what? Your brain is the calculator. And when we were going through it, you'll see that there's like a bunch of formulas that we do. But because we have these formulas, we actually know how to move the beads. The abacus just tracks your numbers and just to see what you can and cannot do. I don't know if Kitty was still here. I think Kitty was the one that asked about that. So if I did this one with a four, if I have four on my abacus, I'm going to add another four. I don't have any more beads to add the four. Guess what? I'm going to go to the cats in the tree. So I'm going to go to the cats in the tree. My hand's right here. I go to the cats in the tree. I'm going to add the five, but I'm going to grab four cats. When I grab four cats, one cat runs away. So when one cat runs away, you just take away the one. That's what I would say to the kids. I wouldn't tell them how to use the money because they don't know what money is at that age, right? So that's why I would talk about five cats in a tree. I said five cats in a tree because I was thinking about, oh, The Incredibles and how Mr. Incredible was saving a cat in a tree. But that helped. A lot of my kids were able to understand that part as opposed to the money. The money is used, I use the money for big people like us because it makes sense because we deal with money a lot. Because we deal with money, it's a lot easier to understand how to deal with it. So we know how to add. We can do it again. When we do the three, right? Again, we're not going to memorize. We're not going to memorize our doubles. What we're going to memorize is understand this concept of how to make a five. So if I have three on my abacus, I want to I want to add three, but that's too much. I have 5 cents, that's too much. So I got to take away the two. So I'm going to show you on my abacus. I have five and I got to take away the two. So my final answer is 6. Cool. So we can do some more multiplication. Multiplication. Okay, how are we doing? Multiplication. All right. You know, this one will be easy. Did I do this one? Oh, yeah. Why does it seem like it's magic? Oh, here you go. Instead of taking away, would it be make sense to 4 plus 4 to count up and then make them read as 8? You know, I was thinking about it, but the difference is when you count up, that's not an abacus. What counting up would be the blocks. I was thinking about this because somebody was being confused. Yes, it would be easier for the kids, but it also depends on how you're doing it, right? So if I give you 4, then we're not doing the abacus. That's fine. Then you don't teach them the abacus, right? So it depends on what your goal is. Every individual is 1, 2, 3, 4, 5, 6, 7, 8. So I would have to count it, or I'd have to break it up, right? So when you do it, you can count up. It's just like doing a number line, but that's not an abacus. It would be easier for the kids. I don't think it matters, honestly. I mean, I probably taught like a few thousand kids and they didn't have a problem with it. And it also depends on, but it's also depending on the teacher as well. If the teacher can explain it. If the teacher doesn't understand it, then it doesn't matter. No, it's still abacus with the 5 block. So let me say that again. It's still the abacus with the 5 block with the first one. So instead of doing, so with the addition of, so with the 3 addition, right? 8. But see, the thing is we don't know. Yeah, hold on, Katie. I'm trying to understand Kitty. Yeah, I was going to do multiplication. We'll do it in a little bit. If I get the 8, right? We add the 8, but that's too much. We have to remove the 2 somehow. 4 plus 4. 4, what am I doing? Am I counting up? If I count up to 8, then you're just doing a number line. 5, 6, 7, 8. But then that's not abacus because abacus is a formula. Yeah, but that's just counting. Then I'm just counting. But then I have to track. Then I have to track to count up. But 5, so I have to remember that's 1, and then 2, 3, 4, and then I look at it 5. You could do that, but then it'd just be the number line. You could start like that. You could start like that. But then when you do, I mean, it's the same. It's kind of the same. You could start that way, and then they slowly understand. But then what you would have to do the same thing when you subtract. If I have 8, I need to subtract 4. Then I have to do 1, 2, 3, and then 4. No, 1, 2, 3, 4. Right? Yeah, I could see it. I could see it. But for the kids, I would tell them just to do this because they're going to be able to see the number pattern. Thank you, Lynette. I feel confident with adding this right. Okay, Michael. Thank you so much for joining. Yeah, I could see it, but then the problem is what? Then you don't transition to understanding the pattern itself because you're going to get into a little confusion when you start getting to the bigger numbers. When you get to the bigger numbers, let's say when we do 99, when we do 99 and we add the 1, we're not going to be counting up. We're going to be utilizing the formulas. So I could see it in the beginning. You could start it in the beginning like that, but I wouldn't be stuck there. There's a reason why we have formulas, and that that way is not a common way, if that makes sense, Kitty. Yeah. Because I'm not teaching you the Lynette way. I'm teaching you the abacus way. This is what's being taught with everywhere around the world, right? Just like we're being taught to memorize our doubles. So I'm not teaching you a Lynette way. I'm teaching you the abacus way, if that makes sense. So I appreciate the thinking. You could start it that way, but I would transition them into doing the formulas because there's formulas involved. The formulas, these are the formulas, and this is what we're doing, right? And so every one of these numbers, you would have to start really understanding this. So these are this is the one set. That's the other thing, right? Like when you're doing this, do you count up to 5? No, you don't count up to 5. We're expecting the kids to know 1 and 4 is equal to 5. 3 and 2 is equal to 5. We're teaching the kids that 2 and 3 is equal to 5. When I want to add the 4, when I want to add the 4 to one of these, right? I don't know. I don't know. That seems a little bit off to me because we teach the kids all these other things. Why would this be any different? Right? This is a concept, and then we modify it. Okay, so we're going back to here. Um, oh good, oh good. Okay, so what are we gonna do? We're gonna do some division. No, multiplication. Oh good. Oh good. Okay, so but you don't need the formulas my way. Well, true, but then when I get bigger ones like this, you're gonna have to do it. You're gonna have to do something because you get bigger numbers. I think it's short-sighted to know that you're only doing it for two digits, right? When the numbers get bigger and longer. So when I have questions, where's my book? See, I think I see what you're saying, but I think that I do still believe that you need to transition it, because when the things get bigger, when the numbers get bigger, right, you're going to have to start doing something. Or the way I saw it on YouTube via HEV. Oh, I don't know how they do it. I know there's other ways, but then you get into like something like this, like you're going to have to count up or you count down. I yeah, I've seen that. That's, I don't know. I think that's an American way of doing things, which is you if you yeah. I mean, it's up to you. You can go without, you can go with, but that's not how I teach it. Is it easier for the kids? I haven't had any problems, so it is what it is. All right. So what we're gonna do is we're gonna do this one. Okay. Okay. Let's see. We're here. All right. What we're gonna do? We did this. So when we're looking, we have to count our digits. When we count our digits, we have one, two, three. And then what are we going to do? We're going to do 5 times 8. 5 times 8 is what? 5 times 8. What's 5 times 8? 5 times 8 is 40. 4 and a 0. And then 5 times 3 is 15. Thank you. Poetic equation. When we do it, we don't need to say 400, because we don't say 80 times 5. What we say is we say 8 times 5, because that's what our multiplication fact is. So what we do is we just do 4 and a 0, and the abacus tracks our number for us, so we don't need to do it. So when we are looking at it, we just need to make sure we add the two columns. And so we have 3 times 5 is 15. Add the 1, add the 5. Oh, okay. Thank you. Not a problem. Not a problem. But that's one thing. Like to change our way of thinking is a different. It's just a different way of thinking. And so when abacus, we try to make it into small chunks. So the chunks are small because we're doing multiplication. If that makes sense. So our final answer is what number? What's our final answer? What number do we have here? So we have 415. Thank you. Yep. So 415, 415. And it'll take us over there here. And then this is easy. Why? Because it's one times digit, which is fine. And then we come down here. And then we're here. Now we do what? 58 times 4. 1, 2, 3, right? How do I know? 1, 2, 3. What are we going to do? 4 times 5. 4 times 5. Thank you, Jeffers. 3 digits. You're right. 4 times 5 is what? 4 times 5 is 20. Thank you, poetic equation. So I have 20. 2 and a 0. And then I have 4 times 8. 4 times 8 is what? Thank you, Jeffers. 32. Add 30, add 2. Make sense? So then if that's 32, what's my final answer? Can you start from scratch videos? I always wanted to understand how to use the abacus. Yes. Hold on just a minute. Let me finish my thought. Yes, thank you. 232. Thank you, Katie. 232. So, Jeffers, this is my multiplication maze. What do you think? So here we are. We do one more and then I'll do a little review for Chile. Right? So we have 3 digits, right? 1, 2, 3. And then guess what? 34. We do what? 1, 2, 3. What do? We do 2 times 1 is 2 times 1. 2 times 1 is a single digit. I go back one column, I add the 2. And then 2 times 7 is what? 2 times 7 is 14. Carry the 1, have the 1, have the 4. So yes, thank you, Jeffers. My answer is 34. Yes, thank you. So did that make sense? So when it's a single digit, right? It actually looks like this. We're going to make it a double digit. When we do a single digit like this, it becomes a double digit like this. Just like how we do time. Our time is what? 104, right? This becomes a double digit. And that's what it is. So our final answer is 34. After that, I found an app that I've been practicing on too. Oh, good. So here, I mean, we know what this is, but to practice abacus, right? We do 3. 1, 2, 3. 1, 2, 3. And then 2 times 1 is 2. 2 is a single digit. I go back one column, I add the 2. When I do 2 times 4, 4 is a single digit. I go back one column and I add the 4. What's the app? And my final answer is 24. And it takes me down to here. All right. So let's do a little review. So that's how multiplication is simply. The reason why is because there is no formulas involved. Okay, so what are we going to do? We are going to do some review. We're going to count on the abacus. Chili, are you still here? We're going to count 1, 2, 3, 4, and then we do 5. Because we have 5, we have 6, 7, 8, 9. After 9, we have 10. It's called Abacus Lessons. It's a brown colored icon. Oh, yeah, I've seen that one. Did you pay for it or is it free? Okay, so how are we doing? Ad based. Oh, yeah, cool. Hey, Lance, welcome. So, what are we doing? We're just doing a little review. So, this is 10. After 10, right? How do I know that this is 10? Because we have our place values. And I got to find my marker. I got to find my place values. Sorry, looking for my placard. There we go. There we go. There we go. Going to bed. Okay, Katie, have a good night, and hopefully I see you in my next live. So we have our place values. When we are looking at it, where do you start and why is it there? Thank you, Create with Caesar. When you notice, I have this ones indicator. I actually have two. I can choose this one or I can choose this one, just like a Pokemon. So if I choose this one over here, because I choose this one, then this will be my ones place. So I have my 1, 2, 3, 4, and then 5. That's 5. We have 6, 7, 8, 9. After 9, we have 10. Does that make sense? And then when we're looking, right? If I then that's why I do this one over here because I have more digits. So now I have ones, tens, hundreds, thousands, 10,000s. When's my next live? I think I was going to go live tomorrow morning. I'm going to go to bed, wake up, and go back to live. I think I'm going to try to go live probably about 7 or 8 in the morning. And then I go live again at night. So I try to go 2 lives in the morning. 2 lives, 2 lives. Are you a teacher during the day? No. Well, no. I'm not a full-time teacher. I've been trying to get my business up and going. I don't have a lot of students. I didn't know. 8 a.m. Pacific Standard Time. So, can you go to a million? Not on this one. This one I would go to a million. Uh, and then I have, if I choose this one to be my place value, this one over here, I have my ones, my thousands, my millions, my billions, my trillions. And then this is a 13 column one. Yeah, I'm trying to get my business off the ground, but we'll see. Um, but or I try to sell my books. So we'll see. We'll see. If not, I'm gonna have to get a real job. I'm gonna have to get a jobby job. so, so yeah. And then if you want, you could choose this one over here. If you choose this one over here, then it'd be my ones, my thousands, my millions. Yeah, cool. Yeah. So it all depends on the amount of digits you have. And so when we're looking, we want to understand that after the ones is our decimals. So then we have our ones. If this is our ones, then our decimal sits between our tenths and our ones. So the decimal sits right here. So it goes ones, tenths, hundreds, thousandths, and then so forth. And then notice that every grouping is a comma. So there's a comma here, comma there. So if this is my ones, my comma would be here. This would mean thousands. If I have a comma here, this would be my millions. So the comma is helpful because it's easy to label. It's easy to see. So that's the one thing about understanding the abacus. Yeah? Cool. Thank you guys. Thank you so much. Wow, I'm at 11K. That's a lot. Thank you everybody for joining. Anybody have any questions? So can you show how to add 109? What? Yeah. Yeah. So what's going to happen? I never enjoyed math. So it's rare to find a class that I really enjoy. Thank you, Michael, for the question. Yeah. So it's really easy. Now, this is where we understand the what? The adding with the formula. So we know, what do we know? We know how to add the one. There's not enough beads to add the one, but guess what? we're going to have to start doing a loop. When we're doing it, we understand that we do plus the 1 is equal to what? Minus the 1, minus the 9 plus minus the 9 minus the 9 plus the 10, right? And then you're going to start seeing a loop. You're going to start seeing a number pattern. So what we're going to do is we're going to add the 1. To add the 1 is what? Minus the 9 plus the 10. So what we're going to do is we're going to minus the 9, right? And when we see it, we're going to minus the 9 plus the 10. Minus the 9 plus the 10. So we're going to minus the 9, and guess what? We're going to plus the 10. 10 is 1 and a 0. 1, 0. So if I do this, this is 1. So again, how do I do it? Minus the 1, I'm sorry, plus the 1 is what? Minus the 9, and then plus the 1. So again, 1, right, plus the 10. So let's do that again. Plus the 1 is what? Minus the 9 plus the 10. Minus the 9 plus the 10. So I'm going to take away the 9. I'm going to add the 10. 1, 0. Notice this is a 1. So I need to add the 1 again. So I can't do it. Plus the 1 is minus the 9 plus the 10. Minus the 9 plus the 10. So I'm going to minus the 9 and then I plus the 10. So again, I need to do 1, 0. And then what's going to happen? I got to minus the 9. So it's like a little loop, like programming. So what's going to happen is minus the 9 and then plus the 10. Can I add the 1 here? Yes. Then I'm done, and I know I'm done. So my final answer becomes 1,000. Did that make sense? It seems so complicated. Hello, Kenzie. Right? So what did we just do? We did a loop. Just like programming, there's loops. So it's interesting. Now we're starting to introduce the concept of looping. Michaela, just for the kids, that's all. Counting up would make it easier. It's super easy once you get the basics. Okay, so how are we doing? Okay. Yeah, I like these types of questions. Oh, we can do more. We can do more. There's a few more that I found. Where is my, let's see. Okay, there we go. So there's this one. If we do 500, let's do this one. Ready, Jeffers? We do 500 in the abacus, right? And then we want to do 300, 600, 300 minus 364. So what are we going to do? We're going to take away the 3. When we take away the 3 is what? Minus the 5 plus the 2, right? And then we need to take away the 6. When we take away the 6, what are we going to do? Do you remember how to take away the 6, Jeffers? Okay, Michael, have a good night. Thank you. So we're going to minus the 10 plus the 4. So we minus the 10 plus 4. Now we're going to take away the 4 again. If we take away the 4, do you remember that one? If we take away the 4, it's what? Thank you. Minus the 10 plus the 6. And there we go. So our final answer is 136. That's it. Right? Hmm. We can do another one. We can do this one. So we have 4,039, right? And then what are we going to do? We're going to take away 1. Remember how to take away the 1? There's not enough beads to take away the 1. So what do? Minus the 10 plus the 9. And then what do we do here? Right? What's going here? If I have to take away the 5, what do? Take away the 5 is what? Minus the 10 plus the 5. And then I do this one. Can we take away the 7? Yep, take away the 7. So my final answer is 3,882. Thank you. Yeah, I do like these questions. It was a lot easier. It's easier to find. But yeah, it was interesting on how they did it. Any other questions? So that's about subtraction. I don't know if I lost anybody, but it is what it is. Yeah. Yep. What's up? Do you always go left to right or right to left, or do you lose? You know what? It doesn't matter which way you go. You just got to track your numbers, right? So that was the one thing. You could start from here, or you can start from here. You just got to make sure you track your numbers. Can you do multiplication? Yeah, we can do multiplication. Hold on just a minute. So let's do this one. Let's go the other way. So if I did 500, right, and I want to take away the 4, yeah, but do you use a strategy to not? Oh, so I use my finger. That's all I do. I use my finger to track it. I don't know if you noticed that, but I use my finger and I say it out loud. I do say it out loud. So if I go this way, no, let's go the other way, right? If I want to take away the 4, I want to take away the 4, I'll go here. If I need to take away the 4, I know it's I'm sorry, it's plus the 6 minus the 10. So I'm going to minus the 10. Can't do it. So what I do, plus the 9 minus the 10, minus the 10, plus minus the 5 plus the 4. And then I can take away the 6 and then take away the 3. Does that make sense? So what I do is I use my finger to track it. After about 30 of these, I start forgetting where I'm at. Yeah, you know what? And I know because it gets a little mind numbing. So because it gets a little mind numbing, okay, Kitty, have a good one. Thank you so much for the conversation. It's a lot easier to solve, a lot easier want to solve this math. Yeah. So yeah, um, you can't do too many numbers after a while because it does get mind numbing. Like even when I'm doing my questions and my workbooks, I do have to take a break because it's a lot. How do you know what the color is in all as a if they're having overwhelming, then just use the single color. That's fine too. I just use a colorful one because it's pretty. It works exactly the same. Okay, so Caesar, was it Caesar? Create with Caesar. Yes, create with Caesar. So what's going to happen is we can do multiplication. When we do multiplication, we can do this one. Um, Multiplication is a little easier. Um, so when I do this one, what we're going to do is we're going to count our numbers. When we count our numbers, right? We count how many digits we have. 1, 2, 3. We know we're going to be 3 digits. So if it's 3 digits, we know we're going to be at the hundreds. 1, 2, 3. So we kind of know it's going to be here. So it's 3 times 5 is what? 3 times 5 is 15. Add the 1, add the 5. And then 3 times 8 is 18. Add the 1, add the 8. And there it is. My answer is 168. How do you know what and the colors of it all? As a special ed kid, it's a lot. Yeah. Yeah, I answered that one. Did that make sense? Create Caesar. Caesar, did that make sense? Okay, Kenzie, did that make sense? You just use an abacus that's single colored. Yeah. Okay, great. I mean, I guess, yeah. I mean, the colors mean nothing. The colors is just there to be pretty. It has nothing to do with anything. The in the abacus, because why? What if the child is colorblind? Can I use this on a test? I believe you can. It would be considered accessibility. And you can ask, but I believe you can label it as an accessibility. Can you do a square root of pi? I That's above my pay grade. Colors have no significance. Yeah. Yeah, exactly. I mean, when people tell me that they're colorblind, then I just use this one. Then there's no excuse, right? I mean, there's a rec and rec, and that's what a 10 beat across. There's a Russian abacus, which is also 10 bead. There's a Kramer, but the Kramer is because special people with visually impaired, so the abacus is more difficult to see. So I don't know. I mean, I would have to really understand what's going on with the child, but I don't deal with. I mean, I deal with autistic children, and they didn't have any problems with it. I had a few autistic children that gone through the abacus curriculum, and I haven't had any problems with it. So my head hurts. Okay, Kenzie, sorry. Tyler, did that make sense? You would have to ask if you can do it. This is cool. Thanks. Yeah, not a problem. Great, Caesar. Oh yeah, so 168. So it takes me to here, right? So then my next one would be same thing. Because I have 3 digits, right? I go to 3 digits. 1, 2, 3. Then my go to what? 5 times 6 is what? 30. Add the 3, add the 0. Don't forget the 0. And then 5 times 4 is 20. Add the 2, add the 0. So my answer is 320. So it takes me to here, and now I'm over here. My question here is 3. I'm still at 3. So 1, 2, 3. 8 times 2 is 16. Add 1, add 6. And then I do it again. 8 times 2 is 16. I add 1, I add 2, I add 6. So my final answer is 176. So it takes me up to here. And then I answer this question. Here is this question. How many columns do I go to? I go to 3, right? 1, 2, 3. Now my question is 8 times 9. 9 times 8 is what? 9 times 8 is 70, 72. And then, excuse me, 9 times 6 is what? 54, right? 54. Thank you, Weirdo. Hey, Weirdo. Welcome back. Thank you, Michael. Yes, 54. So my final answer is 7,704. And that's multiplication. Well, that worked out really well. I like this. Maybe I take out maybe I take out the 1 times. Oh, that's going to suck. No, I'm going to keep the 1 times because it's like a little break. All right. So that's multiplication on the abacus. That's the easy ones. How are we doing? All right. So let's do a little review for those people that just came in. Thank you everybody for joining. So what we're going to do is we're going to read the abacus. To read the abacus, we're going to do some understanding. So this is my abacus. An abacus is a counting tool. This is a forgotten tool. There we go. Interesting. So, for those of you that just came in, my name is Lynette, and I do have abacus workbooks available. And if you're looking for, I do have it in my TikTok shop, or if the ones I've sold out, you can get it here. My name is Lynette, and I've been teaching abacus for 20 years, and now I've been teaching it on TikTok as well. All right. Anybody have any specific questions about the abacus? How are we doing? Oh, excuse me. Thank you so much for the hearts. Thank you so much for the hearts. I appreciate that. Thank you for the follow, Natasha. Oh, and Natasha has a number at the end. You have a number at the end. It says 890. 890 looks like this on the abacus. 890. And there's a zero right here. So 890. 56789. 56788. 890. And that's what it would look like on the abacus. Cool? All right. How are we doing? Anybody have any specific questions? So we did do some adding and subtracting. We also did some multiplication. Okay. Oh, excuse me. We did 11, 12, and then this is accounting at 5 and 6. So what we can do is you know what we could do is we can do this. All right. How are we doing? Let's do some bead recognition. Bead recognition. This is a bead. This is my maze, and this maze is all about understanding how to read the beads. So I'm not sure where everybody is, but let me know what number you think this is. So if I have, I'm going to color it in. Excuse me. My hundreds, my tens, and my ones. What number do we think that is?